A coin is sliding down a smooth hemispherical surface of radius r. What is the height from the bottom where it loses contact with the surface? Here the coin is placed on the top of a smooth hemispherical surface and allowed to slide. At which point or at which height it loses contact from the surface? Now let us imagine this is a smooth hemispherical surface and a body is placed at the point A. As it is sliding down at one point, say when it reaches this point, say it loses contact. Once we say contact loses, then along the tangential path it falls. Up to this point it comes along the surface. Once it loses the contact, it's going to move along the tangential path. So along the tangential path, body will reach the ground. Straight path, tangential path. Alright, let us say this point is B, and imagine the height of this point is H. So if I join this point and the center, imagine this angle is theta. So on the body the weight acts vertically down, which is mg. If this angle is theta, this is going to be theta again. Resolve mg into components. This component becomes mg cos, and this component is mg sin. So mg sin theta is responsible to pull the body down. Normal reaction on the body perpendicular to the surface in contact, say N. It also experiences the centrifugal force mv square by r. Now at any instant on the body, the outward force mv square by r plus normal reaction equal to mg cos. As long as the body is in contact with the surface, this force acting towards the center and force acting away from the center, these two must be equal. Now at the time of leaving, when I say body leaves the contact surface, then n is equal to 0. Therefore mv square by r must be equal to mg cos theta. Or simply I can say m gets cancelled on both sides. So v square is equal to rg cos theta. Take it as equation 1. Now if I observe this figure, what is cos theta from the figure? So let us consider cos theta from the figure. Adjacent side by hypotenuse, adjacent from this point to this point, r minus h, hypotenuse r. Now another thing, between A and B, apply law of conservation of energy. Law of conservation of energy. Let us apply between A and B. So when the body is sliding down, there is a loss in potential energy. This must be equal to gain in kinetic energy. So as the body reaches B, it falls through a height h, and let us say gains a velocity v. So mgh is equal to half mv square, or v square is equal to 2gh. Substitute this v square value and also cos theta into this first equation. So first equation is v square is equal to rg cos theta. Now in the place of v square, substitute 2gh, rg into cos theta value r minus h by r. So we are just substituting these values. Now cancel the terms r and r, g and g. Therefore left side is 2h and right side is r minus h, or 3h is equal to r implies h is equal to r by 3. So at a depth of r by 3 from this top, it is going to lose the contact, or if I say height from bottom, h dash if I call, it is r minus h. So r minus r by 3, which is equal to 2r by 3. So at a height of 2r by 3 from the bottom of the hemisphere, or at a depth of r by 3 from the top, the body is going to lose contact with the surface. So here we are applying three cases. One, centrifugal force condition, normal reaction 0. Second one is law of conservation of energy. So these two are important.